Homework. 1, 2, anything. Anything. Everybody okay so far? Okay. So plan is today, we'll do 1, 3. Focus, 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 focus. So 1, 3 today. Review Wednesday plus test corrections Wednesday. We're probably going to do some test corrections to help you guys out some. I don't want to just to curve, right? I want you to learn from it too. So I figure in order to earn your curve, you'll have to do some test corrections or something. I thought about there's other options. Sometimes I might give like another test, like as a not necessarily a retest, but as another test. We'll talk about that as we go. Okay. And then Friday is a B day. So Monday is your exam over chapter 1. Yes, sir. I told you I don't know, man. Every time somebody asks me that, it drops a point. Every time somebody asks me what is the curve, I drop it a point. Just so y'all know. I hate that you guys are more concerned about a curve than what was on the test. And so when that starts happening, I'll start lessening the curve. Okay? Earbuds out. Earbuds out. I got to clear up this too. If you guys go out in that hallway and you start using your phone and they take it away from you, you have been warned. Okay? Do not use your phone when you go out in that hallway and go to the bathroom. So I am supposed to make you put it in that thing back there. I'm not going to do that unless if I have to. Everybody understand what I'm saying on that? Okay? We got hammered last week at a faculty meeting. And I know it's the 3rd floor and you're probably going to be safe, but I wouldn't risk it. So phones, get those things put away. Bell to bell, do not use them. Okay? And it's really during the flexes. That's when it's really coming down. Just to give you a fair warning. I don't know if other teachers are going to get it or not. But again, I don't want to make you put them back there. And I don't really want to make you put your stuff over there. But that's what they said. They said the problem is when you make them put them in their bags and they go to the bathroom and they put it, and it's in their pocket and they go to the bathroom. So just to let you know. That's when they really don't want you using them then more than in the classroom. They could, I don't say they could care less, but it's more when you go to the bathrooms. That's when they don't want you to have your phones. That's where a bunch of the issues have been coming around. Plus not paying attention in class. Decide that. All right, 1.3, here we go. Here we go. I don't know why this is there. Oh, I needed my button. Here it is. On. A lot of information today. Probably 80% of your exam is going to come from today's lesson. Okay? 80% of your exam. A statistic, that's the very first word we're going to talk about, a statistic. That is a number or a value that is going to come from a sample. A statistic is a number or value that is going to come from a sample. So again, I could find out your GPA. If you guys are my population, it would not be a statistic. Okay? If you are a sample of BHS students and I found your GPA, then you would now be a statistic. So a statistic, watch this. This is really cool how this happens. A statistic comes from a sample. A statistic comes from a sample. Whereas a parameter comes from the population. So that's what they're going to say. The parameter is. Well, as soon as they tell you it's a parameter, guys, you have to know that's from the population. Or if they ask you what is the statistic, you have to know that that's going to come from a sample. And so we have to differentiate all year. Told you a couple things already. Categorical and numerical data. We have to differentiate that. Now we have to differentiate the difference between statistics and parameters. Make sure we know which one we're talking about. Are we talking about statistics or are we talking about parameters? Okay? So 2 values. And again, it's pretty nice. Statistic, sample, parameter, population. Okay? Good enough there. Terminology we've got to know by the beginning. Okay, mean. I don't think I need to spend a whole lot of time on the mean. The mean is the average. The mean is the average. Add them all up, divide by how many there are. The mean is the average of the individual data values. Again, that's not going to change. That has nothing to do with it. To find the mean, you add them all up, divide by the total observations. Here, there is a formula that is on your formula sheet. It looks a little funny. That's the summation symbol. That's a mathematics for summation symbol. And so they will sum up. I think they'll do x sub I. So that's each one of your grades. X sub 1, x sub 2, x sub 3, however many there are, and then they're going to divide it by n, which is the number of grades. And then they're going to say that that is the mean. Any question about that? Okay, so let's sum them up. X1, X2, so they do x sub I over n. Again, it's the mean. It's the mean. Remember the goals that we had, where the 9 and the 10 were way out there. We add them all up, divide by the 20 games, and we'll come up with 3.15 goals. Make sure it's always in the context. Make sure it's always in the context. So there's the mean. We said the center is about 3. The center is about 4. That's okay. But if they ask you for the mean, we got to know the mean, 3.15. Most of the time, they'll give it to you. Very few times will you actually have to find the mean, because that's really nothing more than calculator exercise. So let's talk about the notation. X bar. X bar is the notation for the mean if it's a sample. If it's a sample, they will use X bar, and that's all I'll call it, X bar. If you ever have to type this for some reason, just type X bar. Okay, if it's a test, luckily everything's on paper for you guys, so you don't have to type X bar, but X bar. That's the mean of a sample. The mean of a sample. If it's the population, they're going to use some Greek letters for population. They'll use Greek letters for population. They always use crazy symbols for samples. So if it's the population, they're going to use this Greek letter here. That's the lowercase mu, just a fancy u. Whatever. They don't care how you write it. I just always, whatever. Almost a W. It's mu. M-U for what it's worth. But it's just a fancy Greek letter. So if it's the population, they will use mu. If it's a sample, it's X bar. It's going to be very, very important next semester that you differentiate between these two. To be completely honest, right now, sometimes you won't know if it's X bar or if it's mu. There'll be some instances that you're not too sure if it's X bar or if it's mu. If not, just go to X bar. Just default to X bar. But next semester, there will be no doubt what is your sample and what is your population. Okay, mean. Questions? Good enough? Add them all up, divide by how many there are. Crazy little formula that's on your formula sheet, but I don't think you'll ever need it. I think most of you know how to find the mean or the average. Notation, that's new. X bar, mu. Okay, X bar and mu. Median, we decided a long time ago, it's the one that's in the middle. Median, mid. I know they didn't spell it right. Okay, median, middle. Median is the midpoint of a distribution, right? Make sure you put them in order from smallest to biggest. That is the biggest mistake I've seen for students, right? They'll have all these values here, and they'll look at the one in the middle, and they'll say that's the median. It's only the median if it's in order. They have to be in order. If there are 2 values, it's the average of those 2. If there are 2 in the middle, it's the average of those 2. In other words, there's not an exact middle. So to find the median, range them from smallest to largest. If the n is odd, then it's the middle one. If it's odd, it's in the middle. If it's even, then it's the average of those two middle numbers. Okay? If it's a 4 and a 4, it's going to be 4. If it's a 4 and a 5, it's going to be 4.5. If it's a 4 and an 8, it's going to be 6. So it's the average of those two middle numbers, if it's even set a number of values. They use n a lot as the number of observations. They use n as a number of observations, your sample size per se. So the variable n is used as your sample size a lot. So that's what they mean by the number n of data values. There's no formula on the formula sheet for this, but I hope that's not needed. Good enough with that. Any questions? Got 25 2018 Forerunners. First thing we need to do is make sure that that data is in order. Make sure it's in order. Hopefully we don't ever have one this many. But once it's in that order, because it's 25, it's going to be the middle one because it's odd. Okay? Again, I don't think that they'll give you 25 or you have to count the 13th one. But okay. If it's, there's that 20 soccer games again. So first thing we got to do is put them in order, and then we'll go to the middle. And whatever's in between a 2 and a 2, which is a 2. So the average is 2. Okay. Questions about the middle or the median? So those are two measures of center. Remember, we talk about shape, center, spread. The shape we've discussed, right? It's either skewed left, skewed right, uniform, symmetric, bimodal, right? Now, this is center. You're going to either use the mean or the median. The mean or the median. And if they just ask us for it, we're going to say is about. We're not going to actually calculate it. But if they ask for the median, we got to find it. If they ask for the mean, we got to find it. Everybody good? Question? Hope I'm not going too fast for that. So comparing the mean and the median, this is important to know. So looky here, I got a somewhat of a symmetric shape. Somewhat symmetric. Here's the mean, 22.4. Here's the median, 22.4. What do you notice about the same? Or what do you notice about them? I gave you the answer right there, the same. If the data, oh, I'm sorry, this one, I forgot. Here we go. So we're going to do this one. This one is skewed left. Skewed left. Left. Left foot, left toe, left to the smaller side. There's the mean. I'm sorry. This is the mean. This is the median. So on skewed data, it's going to pull the mean. It's going to pull the mean. Just think about it, simple mathematics. If every single person in this room scores an 80 on the exam, the mean is an 80 and the mean is 80 and the median is 80. If we got a lot of 80s, but there's some 70s and some 90s, the average is still 80 and the median is 80. But we have two kids that scored a 20. That median is still going to be 80, but it's got to pull that average down. It's got to pull it to the skewness. I think I'm backwards from you guys. Nope, I was right. Pull it to the skewness. You okay? So skewed data will pull the mean. On the test, I'm going to give you some type of a shape. This one's bad. And I'm going to say there's number 1, and here's number 2, and here's number 3. And I'm going to ask you which one's the mean and which one's the median. And one of them's arbitrary. Okay? The mean is going to somewhat cut it into, the halfway point, if you will. The median's going to cut it into the 50-50 halfway. So it's skewed. So if it's skewed to the right, and I give you this one, and I give you this one, and I give you this one. And this is 1, and this is 2, and this is 3. 1 is nothing. 2 is probably the median, and 3 has to be the mean. And if you think 3 is nothing, it doesn't matter, then 2 has to be the mean. The mean has to be to the right of the median. No question, because it's skewed that way. Y'all good? Okay with that? That's what all these things say. So that's what this, if a distribution is symmetric, the mean and median will be similar. They won't have to be the same. They don't have to be the same, but they'll be close. They'll be close. If the distribution is skewed, the mean is going to be pulled to the skewness. The mean is going to get pulled to the skewness. So here's where I'm going to tell you something else. If you're describing data, shape, center, spread, right? For the center, if it's skewed data, you really should use the median because that's a better representation. The median is typically a better representation if it's skewed. It's not wrong to report the mean, but a better representation is the median. If it's symmetric, it really doesn't matter because they're about the same. Y'all okay with that? Again, picture most everybody in this classroom scoring an 80, and I got 2 or 3 kids that scored a 20. I don't think the mean is a good representation of test scores. Fair enough with what I'm saying. So typically skewed data, the median is better. Okay, any questions about the centers? Any questions about the centers? So all we're doing, guys, we talked about it the last class period. Now we're actually putting numbers to it. We're putting numbers to the mean and putting numbers to, to the center and numbers to the spread. Okay, a couple pencils going. Anybody need anything clarification on centers? Pretty easy, I think. I don't think it's very difficult at all. Mean, median. Skewed. When it's skewed, that pulls the mean. That might be a little bit new to you. And then notation might be a little bit new to you. Okay, remember that notation because on a test, right, it's different than your multiple choice on your homeworks. Okay, variability. Remember there's 3 things of variability. There's the range, there's the IQR, and there's a standard deviation. This is going to take a little bit of teaching. The range will not. The range is the max minus the min. That's not a dash. That's not a dash. It's the max minus the min. It's not a dash. It's not from the max to the min or the min to the max. It's the number. Max minus the min. Okay? That's the range of the data. We talked about that the other day. Range. Smallest number is a 1. Biggest number is a 10. The range, there is no abbreviation or number, it's just range. We have no notation for it. Range is 9. Really what they would like is that. They really like that. As easy as that subtraction is, they love to see how you got that. Because I'll be honest, guys, if by some crazy chance you didn't see that 10 and you did 9 minus 1, they'd probably still give you an E. But if you just put down 8, they're probably not because they don't have any idea where you got it. Y'all fair enough with what I'm saying on that? Okay? So they really like to see work. As easy as that work is, they like to see work. Oh, just like they did. Oh, then they put goals because they want to be specific. Be specific. Be specific. I'm bad about that too. Caution, it's a single number. We talked about that the other day. It's very common for statistics students. That's actually common for anybody to say that it's a range. I mean, it's a value from here to here. It's not from here to here, it's a value. It's a distance, so it should always be positive. It should always be positive. Okay, question about the range. Now let's get serious. We're going to talk about the standard deviation. Okay, standard deviation. It's going to get used a ton. We won't use the range very much. It measures the average distance from the mean. That's what standard deviation is. You will be asked to interpret the standard deviation. And whenever you're asked to interpret it, that's what it is. It's the average distance from the mean. And of course, we will be specific. We will be specific. So if the average test score is a 80 and the standard deviation is 5, then the average is 5 units away from 80 on that unit test. The average score is 5 units away from 80. That must mean there's a lot of people close to that 80. If the standard deviation was 20, that must mean we're 20 away from 80. That's the average score away from 80. And that's a pretty broad range. Okay? So that's what it measures. Now, let's figure out, now we know the definition, let's show it how to calculate it. Don't write that. Variant. No, let's go. So here's how you're going to calculate it. First, you got to find the mean. Okay? Because to figure out what the average is from the mean, we got to figure out what the mean is. So once we figure out what the mean is, then you're going to calculate each deviation. That's what they call it, a deviation. The deviation is the distance from that value to the mean. Yes, it can be negative. Yes, it can be negative. Calculate the deviation from the mean. So it's the value minus the mean. Value minus the mean. And we got to do that for each one of them. So let me ask you, just think for just a second. Don't answer. Think. If it's a negative deviation, is that below or above the mean? Just think. Don't say anything. So I got the mean. If it's a negative deviation, are you below or above the mean? Everybody okay with that being below? And a positive deviation means that is above the mean. Everybody good? Okay? So we're going to calculate each deviation. Now, if I want to figure out what the average of those deviations are, we typically would add all those up and divide by however many we have. That's what you normally would do, right? To figure out what the average is, you add them all up and divide by how many you have. You can't do that here, because I will tell you every time you will get a 0. Because you're just undoing the mean. So if you have a negative deviation and a positive deviation, all the deviations added up will always be 0, and you can't figure out the average, because 0 divided by anything is 0. So here's what they're going to do. Here's how they fix this. They're going to square each of those deviations. All right, mathematics, dang it. Now I'm starting to play with my head. I know some of you took this class because you didn't think it had math, and some of you are unhappy because it hadn't had math, and now we have math. So we're going to square each of those deviations. Well, real quick now, guys, what is that going to do to every single one of those numbers? Make them positive, right? It's going to make them positive. That's okay. So we're going to add all those up, add up all the square of those deviations, and then divide by n minus 1. Divide by n minus 1, and I put an asterisk right there. So you're only going to divide by n minus 1 if that is a sample, which most of the time it is. If it was the entire population, we're not going to divide by n minus 1 anymore. We're going to divide by n. So unless you have the population, we will divide it by n. Hardly ever do we have the population data, but just be aware of that. Why in the heck do they do n minus 1 and not n? I call it the uh-oh factor. It gives me a little bit of wiggle room, because n minus 1 is going to make a smaller number. And if you divide something by a smaller number, that actually makes it a bigger number. So it kind of gives me a little uh-oh factor, because it's a sample, not the whole entire population. Okay, so now picture what I've done, right? I found the mean. I found each deviation. Once I find each deviation, I have to square those deviations. Why? Because the sum of this will always be 0. The sum of this will always be 0. So what do? They square every one of them. My mathematical nerds out there are going to say, why can't I just take the absolute value? Fair? Take the absolute value, now it won't add up to 0. Y'all okay with what I'm saying? But you can't undo absolute value. Follow what I'm saying? But if I square every one of them, I can undo a square by taking the square root. Okay? So, and that's what you're going to do at the end. Take the square root of that answer after you divide it. Before you take the square root, I should have put this here. That is called the variance. Before you take the square root, that is called the variance. They might ask for the variance. Yeah. Typically, the variance doesn't mean a whole lot because that's all the deviation squared, which typically that's too big. That's typically too big of a number to mean anything to us because we squared them all and we figured out the average of the squares. And the average of the squares is not necessarily the average distance from the mean. That's the average of the squares of the distance from the mean, and typically that's too big to mean anything. But every once in a while, they might ask for the variance. Once you take the square root, that is your standard deviation. Once you take the square root, that is the deviation. This is the formula that's written on your formula sheet. It looks horrendous. It looks horrendous, but break it down. X sub I, that is your test score, minus the mean of all the test scores. And you're going to square that thing. Because this is the deviation, that's the square of the deviation. Well, once you do that to every single one of those, then you're going to add them up. You're going to add them up. And then you're going to divide it by n minus 1. And once you do this, that is the variance. And then once you do this, that is the standard deviation. Oh, it's so nice that our calculators will find the standard deviation just like that. It's so nice that they'll find it for us mathematically without doing all this work. But I think it's very important that you know how that number came about. In fact, it very possibly could be a question of why do we square the deviations? Because if we don't, the sum will be 0. Why do we take the square root? Well, because I squared them and I need to undo the square. Why do we divide by n minus 1? I didn't emphasize that one real well, but that kind of gives me a little uh-oh factor. Okay. Again, this is on your formula sheet if you need it. Notation. If it's the sample, they're going to use just s sub x. That's a lowercase s. That's a lowercase s. If it's the population, they're going to use a Greek letter. And it's just sigma, but it's just circle with a little loop. I think it's up here somewhere. I'll show it to you at some point. Circle with a little loop. Okay. 11, high school students were asked how close friends they have. Here are their responses. 1, 2, 2, 2, 3, 3, 3, 3, 4, 4, 6. Find the variance. Ooh, look, they asked for the variance, and then they asked for the standard deviation. So the first thing we got to do is figure out what the average is. So 1 plus 2 plus 2 plus 2 plus 3 plus 3 plus 3 plus 3 plus 4 plus 4 plus 6, 10, 17, 26, 30, 33. Oh, that's nice. Beautiful. Looky there. Y'all see all my notation, my work. Probably showed more than I'm going to need, but that's gorgeous. There is no way they would take off anything for that. If they ask you for the mean and all I saw was a 3 equals x bar, I'd probably be in trouble. I don't think I'd get an E for that. I don't think I'd get an E if this is all I had. you might get an E for this. This is what I would do if this was a test question. They asked for the mean. I would do 1 plus 2 plus ... 6 equals 33 over 11 equals 3 equals X bar. There is no doubt that that's an E. I don't know if just that is going to be an E. Y'all okay with what I'm saying on that? Good question? Now, all I found was a mean. So now I got to find each of those stupid deviations. So now I got to do 1 minus 3, 2 minus 3, 2 minus 3. I think we don't need to show all that stuff. So 1 minus 3 is negative 2, negative 1, negative 1, negative 1, 0, 0, 0, 0, 1, 1, 3. If I add all that up, it's going to be 0. It will always be 0. It will always be 0. So now I got to square each of those stupid things. So calculate each of those deviations. Here's my notation. Look at my notation. Don't let that fool you. X sub 1 minus X bar. X sub 1 minus X bar. There are some negative deviations. There are some positive deviations. And there are some zeros. Because what? That 3 does not deviate from the mean. It doesn't deviate from the mean. We could make this real easy. In fact, I think this is a multiple choice question at some point. I don't know if it's a practice or on your test. Everybody scores an 80. Everybody scores an 80. What's the standard deviation? That has to be 0 because how much does it deviate from the mean? It doesn't. It doesn't. Okay? So what do I need to do to each one of those numbers now? Square. Got to square them. So I'm going to square that, make it a 4, 1, 1, 1. Those are all still zeros. That's still a 1, that's still a 1, that's still a 9. And we'll add those up. That is this notation here. The sum of x1 minus x bar squared. Uh-oh, I didn't show a 2. I'm too far out of my range. Okay? So sum all those guys up and I get 18. I'm going to take 18 and I'm going to divide it by 10 n minus 1. Divide it by 10 n minus 1. So I'm going to get 1.8. That is not the standard deviation. That is the variance. So here's my notation for this. Y'all okay? S squared sub x. S squared sub x. So that's my notation for variance. And why did I use S and not sigma? Because I'm going to guess there's a whole lot more than 11 high school students. So I'm going to have to think that's a sample. So there's my variance. Then to find my standard deviation, I'm just going to take the square root of that, which I don't have a clue what that is. 1.34. What does that mean? The average number of friends deviates from these 11 high school students by an average of 1.34 from 3. From 3. Yep.
In stats, how many decimal points do you have to round to?
Typically 2, 3. Again, I don't like to say 2 or 3 because if my answer was 0.00004, I probably need that many. Fair? But other than that, they don't care. I typically do 2 or 3. Sample variance, 1.8. S sub x squared. 1.34 close friends in context. In context. Sample standard deviation. Again, you won't write it sample standard deviation. You're just going to write that. That means sample standard deviation. I will get lazy sometimes and not put the sub x. Yes, sir. Scott?
Step 4, the n minus 1.
Yep. 11. Yep. 11 of them. N is always your sample size, typically. How many data values you have. Anybody else have a question about this? You will have to do this for your homework. You will not have to do this for the test. Because again, it just comes down to numbers. You either know how to do it or you don't know how to do it. Picture me asking you a question of how you would do it or why you do something, but I'm not going to ask you to do it because really you either know how to do it or you don't know how to do it. And if you know how to do it and you get it wrong, it's because you just messed up. It doesn't test your knowledge. And if you don't know how to do it, then you still don't know how to do it. And you don't, I mean, that has nothing to do with getting the right or wrong answer. If I can give you to understand anything, that right there will be asked on the AP exam. Interpret this value. Interpret this value. Context. The number of friends for these 11 students typically varies, or you're okay with deviates, by about 1.34 from the mean value of 3, or from the average of 3. You don't have to say it exactly like that, but I will guarantee it. That's the part right there that's going to get you the E. The typically varies. Typically varies. Typically deviates. Average deviates. Something that matters. And then from the mean. They're going to want 3 things. They're going to want 3 things to get the E. Typically varies from the mean in context. In context. So the number of close friends, these students, not all students, these students, because that was just a sample, typically varies by 1.34 close friends from the mean of 3. And you probably don't need to say 3 close friends again. I think we're being too much context, too much. Or we could probably say 1.34 from the mean of 3 close friends, as long as you got it in there. But if you can, I guarantee it. I'm telling you. They don't tell me what's on the test, but that's on the test. That's on the test. Interpret this value. Question, standard deviation. Standard deviation. Standard deviation. I'll show you how to do it on your calculator in just a second. I think I've talked about this already. The notation S sub X refers to the standard deviation of the sample. There's that little sigma. Sigma sub X refers to the standard deviation of the population. Okay. Please remember, this one is divided by n minus 1. This one is divided by n. This number will always be bigger than this number. Because if you're making it bigger on bottom, that has to produce if you're making it smaller on the bottom, that has to produce a bigger number. So this number will be smaller. If your sample size is 200,000, you're dividing by 199,000, which probably is not going to change much of anything. But you got a pretty good sample size. Okay, several pencils are going. Who has a question about anything about standard deviation? You got to know the interpretation. You got to know the interpretation. The value of this typically varies by about from the mean. Properties of standard deviation, which are S sub X will always be greater than 0 or equal to. If it's equal to 0, that has to mean that everybody is the same score or everybody has the same value. That's the only time it will be equal to 0. So it will always be greater than 0 because you squared them, you added them up, it's always going to be a positive number. Okay? Here's from the duh factory. Larger values indicate greater variation. Larger values indicate greater variation. S of x measures variation about the mean. Duh. Again, we've kind of just making sure we're emphasizing all of this stuff. Any questions about standard deviation? How am I doing? Not bad. So we got mean, median, range, and now standard deviation. Mean, median, range. Those are really easy. Need a calculator for mean. I probably don't need a calculator for median. Probably don't need a calculator for range. I'm going to have to use a calculator for standard deviation. I'm not doing any of that in my head. Especially taking the square root of something. Okay, one more. IQR. Remember, you have the range, you have the IQR, and the standard deviation. Those are three ways we can talk about the variability. Three ways we can talk about variability. Range is the easiest, but it's probably the least, I don't want to say accurate, least precise, least way of explaining it. I mean, the range could be 20, and that's still not going to, I mean, I may have two outliers. If I got two outliers, that's not going to help me a whole lot. Right? The IQR and the standard deviation will help remove those outliers. So let's talk about the IQR. First of all, we need to talk about the quartiles. Quartiles, quarters, quarters, quarters. So you got it divided into 4 groups. That is the median. Right in the middle is the median. So then I'm going to divide this into the median and this into the median. And that's going to divide it into 4 groups. This is the first group. Here's the second group. Here's the third group. And here's the 4th group. This is the median. They're going to go way out on a limb here, and they're going to call this Q1. Ooh, quartile 1. Careful now. Careful. Q3. Because what's Q2? Median. Okay. Wait a minute. If I'm dividing into quartiles, why are there only 3? Because you have this side and this side of those. 1, 2, 3, 4. I know. Sometimes we don't like, that fought me forever. Why don't I only have 3 numbers if I'm dividing up into quartiles? Because that divides it up into quartiles. Median, which I put Q2 there. Here's Q1, here's Q3. Okay. The first quartile is the median of the first half. The third quartile is the median of the second half. Let's do this. 1, 2, 3, 4, 5, 6, 7. There's the median. Right? There's the median. I can't split that number. I can't split that number. So if it's an odd set, guys, I'm just going to forget about it. I'm going to forget about it. And here's Q1 and here's Q3. If it's an odd set, I'm going to forget about that number and I'm going to find the median here and the median here. If it's an even set, whoops, that's not, I want this one. One, 2, 3, 4, 5, 6, 7, 8. Whoops, there. There's the median. And then I'm going to split it. And then I got to find the median here, and then the median here. So if it's an odd set, you forget about that number. And an even set, you can split it. Even set, you can split it. Oh, I'm ringing. I don't have my phone with me because I'm trying to be like you guys. Coach Mayor. 10-4. Okay. Ethan Bedore, North Office. Make sure you check out through the North Office. Okay, here's 20 New Yorkers. 20 New Yorkers. First of all, those 20 New Yorkers, put them in order. Please put them in order, because you can't find medians if you don't put them in order. Once you put them in order, you find this median, which is 22.5, because that's what's in between 20 and 25. Stay with me. Stay with me, guys. Now I need the median here, which is in between 15 and 15, and I need the median here, which is 40 and 45. There's Q3. Your IQR. And yes, you can abbreviate that IQR. There's no symbol for it, but you can abbreviate IQR is 42 minus 5, 0.5 minus 15. That's the IQR. It's Q3 minus Q1. It's the range, inner quartile range. So it's like the high minus the low, but it's not the high minus the low because that is the range. So it's Q3 minus Q1. There it is right there. Q3 minus Q1, 27.5 in context minutes. In context minutes. This was travel times for New Yorkers. Little bit easier than finding the standard deviation. Yes, because standard deviation, I would have to find X bar. That would take a while. Then I got to find each deviation, X minus X bar. Got to find each one of those, so that's 20 of those. Then I got to square those numbers. Then I got to add those 20 numbers up. Then I got to divide it by n minus 1, where I got to divide by 19. And that's the variance. Then I got to take the square root to find the standard deviation. IQR is a lot easier, a little bit quicker, and a little bit more precise again than the range. A little bit better value than the range. Any questions about IQR? Interpretation of the IQR. Again, guys, you got to know these interpretations. You got to know these interpretations. It's the middle half. The middle half of the data. Context. It's the middle half. So you're dividing this up into quartiles. 1, 2, 3. This is 25%. This is 25%. This is 25%. And this is 25%. So it's the middle half. It's the middle half. So 50% of the data is between this value and this value. The range, 100% of the data is between this value and this value. The 100% of the data is a distance of 9. 50% of the data, the distance is 2. Whatever it is. The range of the middle half of travel times for the New Yorkers in this sample is 27.5 minutes. Again, this is not the population. It's just that sample. So don't say all New Yorkers. Mean, median, range, standard deviation, IQR. Shape, center, spread. Now you can put numbers to them. If they ask. If they don't ask, I'm still going to just estimate. Get close. Don't lie. But if they ask, put those values. Click. Identifying outliers. You'll have to do this on the test. You will have to identify outliers on the test. So it's not that difficult of a formula. Listen to what I call the rule. It's called the 1.5 rule. That's what it's called. That's what it's called, the 1.5 rule. So here's what you're going to do. IQR times 1.5. Good enough that? Now, we're not done. But once I do that part, I'm going to take whatever that number is and add it to Q3. Let's call it, I don't know, call it F. Fence. I don't know, making that up. 15 years, I just made that up. Call it a fence. That looks like an E now. And do Q1 minus that fence. Anything bigger than that, anything smaller than that. I might have this part backwards. It might be the fence minus Q1. No, it's Q1 minus that. Anything bigger than this, huh? Yep. Yep. Y'all okay? All right, let's go through it. Although there are several rules for outliers. AP Stats uses the 1.5 rule. So here, let's see what this is beautiful. Look at all this. Wow, this is nerdy. 1.5 IQR above the third, below the first. So low outliers are less than Q1 minus the 1.5 IQR. I did do that right, didn't I? Yeah, minus F. And the high outliers are greater than Q3 minus that. Now we've talked about the unusual occurrences. We find the IQR. We multiply it by 1.5. We add it to Q3. We subtract it to Q1. If anything's smaller than that, it's a low outlier. If anything's bigger than that, it's an upper outlier. This is that New York, Highway File 25, Forerunners. Yuck, right? Here's Q1, 22.2. Here's Q3, 22.6. There's the IQR 0.4. So we take the IQR times 1.5, 0.4 times 1.5, and that's going to be my F, or whatever you want to call that. We will add that to Q3. We'll subtract it from Q1. And if anything's bigger than that or smaller than that, they're outliers. High outliers. There's Q3, 1.5 times the IQR, 23.2. Barely an outlier. Barely an outlier. Low outliers. There's Q1 minus IQR. 1.5 IQR, 21.6. Jiminy Christmas, barely. Barely. So when we first talked about this, we easily thought those were outliers. Truthfully, they're just barely outliers, but they are. Both, there's an upper and a lower outlier. The cars with fuel economy ratings 21.5 mpg and 23.3 mpg will be considered outliers by the 1.5 IQR. Beautiful. We're almost getting there. Hey, woo, math, woo, yay. We've done some numbers, we've done some math. Look, we did multiplication and addition and subtraction. And we've squared and square rooted. Woo! Math! Whoop, whoop! Okay. Resistant. They're going to throw this word at you, resistant. When a statistical measure is not affected by extreme measures. When a statistical measure, mean, median, standard deviation, IQR, range, mode, which we don't, I'm not even going to talk about mode ever. We're done talking about mode. We're not going to use it. So mean, median, IQR, standard deviation, range, statistical measure is not affected by extreme measures. And I kind of think of it as an outlier. I kind of think of this as an outlier. So, watch. Everybody scores an 80 on the test. Everybody scores an 80 on the test. The mean is 80. The median is 80. The range is 0. The IQR is 0. The standard deviation is 0. I don't know what else there is. Well, okay. So then I got this. Now I got this. Let's do this. Go away. Let's put 2 of these cats. Okay. Mean, 80. Median, 80. IQR, I'm going to guess is 20. Maybe not, but close. You got to play along. IQR 20. Range, 20. Good enough. Extreme measures. Got that idiot down here that did 20. Is that going to change the median? If it does, it's changing it from 80 to 75. Fair enough. Not changing it much. Is it going to change the mean? Yeah. Yeah. Going to change the mean quite a bit. IQR? Nope. If it does, it's changing it just a little bit because this number might, well, no, in between 7, it's not even going to change it at all. Range? Dang right. It's changing the range. Standard deviation? Dang right, it's changed the standard deviation because you got an average that's way away from the mean. So which of these are resistant? These are the ones that are resistant. The median and the IQR. If I have an extreme measure, it's not going to change the median. It's not going to change the IQR. These are not resistant. Mean, standard deviation, and the range. Because if I add something way away from the mean, it's definitely going to change the average. It's definitely going to change the standard deviation because that's the average different from the averages. And it's going to change the range. It's important to know that. Because why? If you have an outlier set of data, you probably should not use these things to report it. The mean, the standard deviation, the range. Kind of goes with my skewness. When it's really strong skewed, I should report the median. If it's really strong skewed, I should report the IQR as the spread. Why? It just gives me a better picture. It gives me more, I don't want to say a more true value because it's true. It just, and I don't want to say accurate because they're both the same accuracy. More precise. How about that? More precise it's going to give me. Okay? More precise. It's going to give me a better picture if I report these with an extreme measure because these are resistant. They're not affected by the outliers. 10, 11. Vocab. I'm almost done. Just got a standard, I got to show box and whisker plots. All right, everybody good? Okay. 5-number summary. 5-number summary. You already know 3 of them. You already know 3 of them. Is it going to mess you up if I call it Q2? I'll do both. Median and Q2 is one of them. Q1 is one of them. Q3 is one of them. And the other 2 I need are the min and the max. That's a 5-number summary. 5-number summary. Minimum, Q1, median, Q3, max. 5-number summary. It is very possible they ask you for the 5-number summary. It's very possible they ask you for the 5-number summary. Median, Q1, Q3, minimum, maximum. 5-number summary. Good enough? Questions? Easy? I mean, I don't think those are real difficult. Once you find the median, then we got to find another median, and we got to find another median, and the minimum and maximum are real easy to see. Once you have that 5-number summary, we could draw a box plot. It's a visual representation of the 5-number summary. 1, 2, 3, 4, 5. Number line, right? Don't just put the numbers. Make sure we have easy intervals, right? Box plot. We used to call them box and whiskers. That's the last graph we're going to talk about. We talked about dot plots. We talked about histograms. We talked about, what was the other one? Dot plots, histograms. Dot plots, histograms, or something else. Bar graphs, thank you. Well, that was something numerical. Click, okay? So, to find the 5-number summary, of course, you have to identify. Now, here's the trick part of this. If there's an outlier, we have to represent that with this box plot. So, watch. I always debate about how to do this. I probably didn't do it right again. Here's Q1 and Q3. So that's a box. There's Q1 and Q3, and Q2 somewhere in here. Okay? This whisker will go out, listen to me, not to the fence. Not to the fence. It's going to go out to the last data value. Do I have these data values? I don't know where I put them.
Just goes out as far as the 1.5 rule?
No. It goes out to this number here. So it does not go out to 23.2 because that's not a data value. That's not a data point. So don't put it out to this because that's not a data point. It's not important to us. That is a data point, so put it out to the 22.9. Don't put it out to 21.6. Put it out to 21. Ooh, there's 2 outliers. No, there's not. The other way. Put it out to 21.9. That's an outlier. Okay, so let's go through all this stuff. Try to clean it up. All right, here we go. Identify the outliers using the 1.5 IQR rule. Okay, so here we go. Notice now, guys, look here, 21.5, 22, 20, that should be common intervals. Common intervals, okay? Here's Q1 and Q3, 22.2 and 22.6. There's the median. The whiskers extend to the last data value that's not an outlier. That is, if anybody's going to mess up, that's where they're going to mess up. They're going to put those whiskers out to the fence. Don't put it to the fence. Put it to the last data value. Because the fence is not part of my data. So don't put it to the fence because that's not part of my data. And then I'm going to mark these outliers with asterisks. I'm going to mark them with asterisks. You can mark them with X's, asterisks, dots, extra, whatever. It doesn't really matter how you do it. I always just do an asterisk. Remember that, like histograms, stem and leaf plots was the other one. Box plots do not retain the original set of data. They're like histograms. They do not retain the original set of data. I can't go back and tell you what values are in there. What values? I can tell you what values that contain, but not what's in it, okay? Box plots do not show gaps. They do not show clusters. They do not show peaks. They don't show that stuff. Okay? Be careful of that. Just kind of make sure you're aware of that. I remember now what I have that will be fun to do. I don't know if I'll have time. Advantages of box plots. Easy to draw. 5 numbers, you're done. They're very convenient in handling outliers. Their construction is not subjective like a histogram. Remember, histograms like in pancake or skyscraper, I can't do anything to these. Everybody's box plot's going to look about the same. The only way it might look different is if somebody goes by 2s or somebody goes by 1s or somebody goes by 10s. But the box plot's still going to look the same. It's going to be shorter or longer, but proportionally, it's going to be the exact same. Typically, you use these for larger data sets. Larger data sets. Disadvantages. It does not retain the original sets of values. We should not use it for small data sets, right? Guys, if I only got 5 numbers, it wouldn't make sense to do a box plot. If I only got 10 numbers, it probably wouldn't make sense to do a box plot. All right, guys, I hope that you can measure the center. I hope that you can measure the variability. I hope that you can explain how outliers affect the center and the variability. I hope that you can identify outliers. I hope that you can make and interpret box plots. I hope that you can use box plots and numerical summaries to compare distributions. I didn't do one of those real quickly. Bear with me. You can't see the bottom. The median of the bottom one is larger than the median of the top one. The IQR of the bottom one is larger than the IQR of the top one. I guess they're both somewhat symmetric. I don't know. Symmetric's hard to tell. That one's skewed left. Yes, no, maybe. We'll see. Your homework should be posted. Exit.